Welcome back to the Heflinger Podcast. It's episode 27. We have a very exciting episode today. It's all about preventative medicine and the power of DNA. We have a special guest. His name is Kian Sadeghi. He's a 25-year-old CEO and founder of a company called Nucleus Genomics. And what this company is all about is to map your DNA, your genetics, to help you with your healthcare in the future. Kian, when he was 6 years old, had a 16-year-old cousin who died in her sleep from a rare but treatable genetic disorder. And ever since then, he's wanted to do something about that. So 15 years later, he started his own company to deal with people's genetics and how that can help with your healthcare in the future. He's very passionate about it. And Kevin and I had the opportunity to take a genetic test through his company this summer. We really liked it. I like the information that it gives you. And I think it's something that's really going to be important in society as far as preventive medicine for the future. So we decided to partner with this company. We're really excited to have Keon on the show today. And he's going to tell you a little bit about himself and how he became interested in genetics and how he started this company that I think is going to change things. But we're really excited to have him on today's episode. Anything else, Kevin?
No, thanks for joining us. We're excited to talk more about it. Yeah, so Dad, talking about preventative medicine, how would you kind of define that for people who may not know what that is, or from a physician's standpoint?
Yeah, I think the simplest way to look at it. So you look at it from my world. People come to see me in my office when they already have a problem and it's too late and they need to have it treated. Or if a person goes to their primary doctor and they have high blood pressure, they have diabetes, and they come to get the medications to get it treated because they already have it. So in my mind, what preventative medicine means is to not get that disease so you don't have to treat it. So what can you do in your life to hopefully prevent some disease from coming on? And obviously there's steps that you can take. I mean, obviously, just we all know the stuff you hear on social media and TV all the time: eat healthy, exercise, get enough sleep. We all hear that. But what we don't hear much about is genetics, because you have a blueprint in your body that tells you everything about your body. And it can even, and you're going to learn from Kian about some of this more than I can tell you, but it really can predict what you're likely to get in your lifetime as far as diseases, which is super exciting and super powerful. But so that's where I see preventive medicine. I mean, I think it has to move. Our society has to move towards preventive medicine, because it can't sustain people getting so many medical problems and trying to treat them after the fact. We really have to get ahead of the curve and start preventing conditions from coming on.
Yeah, definitely. Kian, what do you think about it or how do you think about preventative medicine and in its role?
Yeah, I absolutely agree with Brian. I think it's all about stopping the onset, or at the very least progression, of disease, right? So we like to say that we're shifting healthcare from sort of a sick care system to one that basically empowers patients with information that they can use to stave off disease. And genetics is really the foundation of your health. So, I mean, people kind of know this intuitively already, right? You get some of your DNA from mom, some of your DNA from dad, and then that is the kind of blueprint, as Brian said, of who you are. Also, it's the blueprint of what you're at risk for. People know this via family history. People often say, oh, this disease runs in my family. This disease, affected my grandmother, my mother, etc. And what genetics can do, it actually can tell you and give you peace of mind if a disease is in fact inherited in your family, or often actually uncover risks that you might not even know exist in your family. There were some interesting studies that showed more than 50% of hereditary cancer cases, there was actually no known family history for them. And I think about that a lot, because you can think about family history as the first step, but actually still kind of fuzzy, and genetics really giving you a clear quantification, a clear kind of personalized measure of your unique risks.
What do you think, like currently, that genetics and DNA testing, what are like some of the most like prevalent things that it can help prevent or identify, I suppose?
Yeah, I think of kind of genetics in almost three main buckets. The first one is what I call urgent and extremely actionable. So these are kind of genetic insights that could potentially save your life. Brian mentioned this earlier about my cousin, who unfortunately went to sleep one night and she didn't wake up the next day. She actually was suspected to have a condition called long QT, Long QT is a condition where it causes irregular heartbeat and cause sudden death. Long QT is a condition where if you know you have this genetic marker, you can take something called a beta blocker, which is actually a drug that reduces your chances of dying of the condition by, an order of magnitude. That's a great example of a condition of both kind of genetic insight creates a kind of preventative actionable step that helps you stave off disease. That's rare though. There's other conditions that moves to the middle bucket, which is not necessarily urgent, but it's important and actionable. So one of the most famous examples of this is actually Angelina Jolie. In 2013, I believe, she came out with having a BRCA variant. So BRCA gene is associated with breast cancer, so it increases your risk of getting breast cancer from about 13% if you're a typical woman to around 60 to 80% estimate. Um, and once you know you have this BRCA variant, you can take different measures. One is early and more aggressive screening. Another, for example, is a double mastectomy, right? Effectively preventing yourself of getting breast cancer despite you at a much higher risk. It doesn't just stop at breast cancer, though. It's also, high cholesterol, also known as familial hypercholesterolemia, also colorectal cancer. And there's actually over 70 genes that the American College of Medical Genetics outline that are all actionable. And to me, you might be asking, like, how relevant is this actually? It's remarkably relevant in the US population. There was a great study that focused in on breast cancer, colorectal cancer, and high cholesterol. And they found that actually 3 million Americans, an estimate, do not know that they're a dramatically higher risk for one of these three conditions, right? Yet have one of these what's called pathogenic markers, these markers in their DNA that dramatically increase their risk. So 3 million Americans don't know. And to me, that's always very a stark number, because the 3 million people is, it's my mom, it's my dad, it's, my friend, it's my cousin, So when you think about it from that perspective, yeah, you think, wow, that's amazing that, a swab could basically identify these millions of Americans that are dramatically higher risk for condition that could basically, a swab could save your life, but they don't know.
Yeah.
And that to me really, really sticks with me a lot as I think about kind of our work and what we want to do for broader healthcare.
Kian, maybe for people who don't really understand genetics at all, just can, in a really simple way, can you explain to them what genetics as far as their genome is? Like, what are you testing so they understand what it is,
Yeah, I like to think of your genome almost as like a book, right? So it's like 1,000-page book. There's chapters in your books. You can think of these chapters as genes almost, right? Each gene sort of, is a story within a broader story. Um, and if you think about genetic tests historically, they would look at different chapters. So let's say I have a book with 10 chapters. One genetic test might look at chapter 5. Another genetic test might look at chapter 7. What Nucleus does, part of our innovation, is we look at every single chapter in your book. And what's so amazing about that is you don't actually need many different genetic tests now. You can combine there's around 70,000 genetic tests in the United States into just one. So we look at these chapters in your kind of DNA, in your book, in your story, and then we use this information to tell you your risk of getting different diseases, which then you can confer and use to help stave off these conditions. Because obviously the first step of any sort of preventative medical system is risk identification, right? You obviously can't stave off something you don't know you're at risk for, and everyone's at a different risk. So given that, they should all take different necessary precautionary steps, which can range as I outlined.
Tell us about your background, your schooling. People are interested. I mean, here you got this genetic company, and genetics for most people they don't understand. It's like brain surgery. It's one of those things they don't comprehend. So how did you come to be able to create a company like this? And what was your schooling? I mean, you must be exceedingly smart, obviously. And so what's your background? People probably love to know.
Yeah, so I became very interested in genetics as, after my, cousin unfortunately passed away. And I actually, the first thing I went into was thinking about, well, disease, it's actually, something I really grappled with when I was younger is how is that, my cousin dies, but I'm alive? And that's a very naive question. It's the kind of question a child would ask. But then you start realizing that, like, disease, especially early onset disease, isn't really almost a property of human beings. Like, they don't need to die, right? That's kind of the realization I made. And so I started thinking about genetic engineering, actually. So that's how I went in high school. I joined a genetic engineering lab, and it's actually interesting because these different technologies have kind of really progressed in the last half decade, a little bit more than that. And I started thinking about, we started playing with yeast. We engineered yeast to make them eliminate. We added bacteria to make them resistant with antibiotics. And at the time, there was actually an interesting study basically using CRISPR, which is the gene editing device. So you basically swapping out, like, if your DNA is made up of letters, so you use the gene editing device to change letters, basically. And it was focused on a disease called retinitis pigmentosa. And retinitis pigmentosa is a disease that causes blindness. It's a genetic disease that causes blindness. There's basically a point mutation. So point mutation, we don't use the word mutation anymore really in genetics. It's actually one of those interesting things. We kind of moved away from it for a lot of reasons because there's so much connotation there. But a point mutation, or you can think of it as a variant, just a single DNA difference or error, especially an error in your DNA that causes some sort of disease. So what the researchers at the time were trying to do was trying to use this gene editing device to basically correct for or update this letter to get rid of blindness for someone, right? It's more complicated than this, but this is basically what they're trying to do. And what was amazing, that was very much research at the time. And now you can actually see that has radically developed. And you can see this becoming more and more sophisticated to actually become a tool for curing blindness. So I love to see that from something going from the research all the way to kind of, patient side. And there's still some ways for it to go, but in that way. So that kind of became my first interest in genetics. There's actually an article of me at 17 in the Wall Street Journal for genetically engineering organisms. That's always a funny little anecdote. So I like genetics. I've been interested in a long time, and to me that was like hacking kind of biology, or like playing with biology, and I wanted to make it more iterable because I loved the beauty and depth of biology. But the one thing about the wet lab when you deal with pipettes is that it can be so long. Like if you make a mistake, forget about it. Like you have to run everything again. It takes another week to do it. But on the computer, if you make a mistake, you just click the delete button. So it was just so fast. I really liked that idea. So I want to almost combine these two things, the world of, bits with the world of atoms. Or the world of genetics with the world of programming. And so I went to Penn to study computational biology, which is basically these two things, right? Right? Biology, people know what that is. Computation, this idea of like bringing in computer science to biology. And I was in genetics class one day, and literally the chairman of the biology department at Penn, he brought up the decrease in cost of reading an entire human genome. And as mentioned, it used to be 10 million per sample, and at the time it was like around 1,000 per sample. And I thought to myself, this price is going to converge on zero. It's sort of an inevitability that every single person in the world is going to get their human genome sequenced. Someone needs to build the software layer for DNA. So I actually moved out of school, moved back into my bedroom in Brooklyn, and I started literally working at this. And I have a very extreme personality, so I just gave it my all. I gave everything I had, and eventually I realized, like, hey, I can actually kind of provide myself, because I actually originally built Nucleus for myself because I wanted to analyze my DNA, and I thought, I can actually provide the most comprehensive assessment of someone's genetic risk for disease that's really ever been available. That was my realization. And then once I had that realization, I just knew I had to build the company. How could you not? So that's how it got started.
People probably wonder, what's the accuracy of it? Like, what is the accuracy of having your genetic testing done?
Mm-hmm. Nucleus is actually over 99.9% analytically validated. So we're regulated by the U.S. government, and we basically have to show that our test works. So it's a bit of a long process, but it's a process we really appreciate doing, so we can ensure and know that we give customers extremely high quality and accurate results.
Yeah.
Back to the fact that like almost it's estimated up to 80% of Americans haven't had a genetic test before.
And Kevin, I want to say something on that was interesting, which is that in that statistic, when I gave the analogy of the chapters, when that statistic, I imagine it's talking about even older genetic tests, right? Like genetic tests that look at one chapter, two chapters. Think about whole genome testing, which is our testing, looks at the whole things. It's like less than 0.1%, which is amazing. Yeah. Sorry, Kevin, please go ahead.
Oh, no, exactly. That's what's crazy, because this is including, I think, probably a lot more people. You guys are a lot newer. I think I've heard 23andMe or Ancestry.com were early or mid 2000s. You might know better than I do, but they've been around a lot longer. I think that's probably where more people who have taken a genetic test have taken one of those. But yet Nucleus is testing up to 1,000 times more, if I'm correct on that.
Yep, exactly. That's exactly correct.
But so why do you think it's just like like an information or education gap? Like maybe it's something, I know some people won't go get their blood, like maybe their triglycerides tested. They don't want to get their blood drawn. Some people don't like doing that. When we did the Nucleus test, it was just a simple swab. It was very easy to follow. I think each of us, it took like 5 minutes once we knew how to do it.
You just swab the inside of your mouth and then you put it into a tube. They give you a prepackaged device to send it back. It's very, very simple to do. No brain.
Super
no
easy.
brain. Yeah, super easy.
It was easier than I thought. I didn't know you could just kind of take a DNA swab like that and that you could then get all this information unlocked. Do you think a lot of people, that's kind of what's preventing so many people from getting testing done? Or do you think it's also that they're scared of the potential results?
Well, I think a big part of probably they don't understand the benefit of it. You know, people don't want to do something if they don't really think, what am I doing this for? What am I getting out of it? So I don't think people understand the extreme benefit they can get from knowing, you know, what they're at risk for in the future, you know?
Yeah, I think there's a lot of reasons. Definitely one of them is people don't know the benefit. I think people, if you think about blood tests, for example, as a comparison, a lot of people are, you know, they have some intuition for blood. They kind of get, you know, it annually maybe from their doctor. They have some concept of LDL, for example, as a risk factor. But when you start taking, like, think about genetics, right, there's no sort of integration of genetics today into kind of a typical healthcare stream. Usually if it's some sort of extreme indication, or even after, if you think about Medicare, the largest insurer in the United States, they actually only cover a genetic test after you've been diagnosed with cancer, which I think says a lot about our current system and the problems, frankly, with the current system. It's very disheartening. I mean, it kind of defeats the purpose of, you know, the genetic result. Anyways, so that's one issue. I think a lot of misconceptions about genetics as well. One misconception is that people think that if they do genetic tests, then actually, you know, an insurance company can use it to price their premiums. That's actually illegal. In 2008, the Genetic Information Non-Discrimination Act, GINA, made it such that it's illegal for any any health insurance company specifically, to use genetic data to price premiums. And that actually legislation was passed to make people more comfortable to take a genetic test because of its benefits. That's another reason. I think also, if you look at the older genetic testing companies like 23andMe, people tend to think that's what genetics is about. They think this little,
like,
you know,
ancestry,
small ancestry is about genealogy, it's about, you know,
right.
is my hair red? They don't really associate with the medical benefit.
That's a great point.
And so that, I think, is something that we're really trying to get out there, which is like, look, this isn't just about, you know, the color of your hair or where you're from. This is about something that could potentially save your life. And from that perspective, I really think anyone should get a genetic test, because it's simple, right? There's not like a blood test. You don't know blood draw. It's just a swab, as you mentioned. It's fast. It's easy. It's convenient. And then you have results for life. Your DNA doesn't change. So,
and I think, you know, a lot of it, you know, you're talking about genetic testing. People think of rare diseases, like it'll pick up on rare diseases, and it will. And that's important. But I think for the general population, what we're talking about is preventative medicine. And so, like, Kevin and I had a chance to take the test, and so did my wife, and we got our results back. And so, you know, I have mine pulled up here, but, you know, what it looks at, it tells me what I'm elevated or likely to have in the future. It tells me what's my average. You know, I have an average and I have a low risk. So I have a higher risk, an average, and a lower risk. So under my elevated or high risk conditions was high blood pressure. And so I don't have high blood pressure, but genetically I'm increased risk to have high blood pressure. And maybe, you know, my wife never had it and she has it now. She developed it 2 years ago out of the blue, and she's 63 now. So it can happen. So for me, what do I do with that information? Well, what I do with that information is, you know, I'm going to definitely try to exercise more, which I already do. I mean, I try to eat healthy and exercise, but it's a good reminder that I need to keep exercising. I need to keep eating healthy, maybe meditate, you know, to help. I don't meditate. I used to, but I need to start doing that again. All those things can help lower my blood pressure. So there are things that you can do proactively to prevent high blood pressure from coming on, decrease your salt intake, but all that, you know, if you know you have an increased risk of having it, I'm more likely to do it. You know,
exactly.
And I think that's what people need to understand, you know.
Yeah, no, I think it's just like when you get your blood work done and you notice something. I think some people specifically like want to keep their head buried in the sand, so to speak, because if they don't know they have a problem, they don't have to make any changes. But I think you're just, as a self-starting individual, you're much more likely to increase those positive habits. And
like, what was one of your elevated ones, Kevin? Because you're a lot younger than I know. So.
One of my elevated ones was asthma, also insomnia. Asthma, though, my sister actually has asthma, and I think.
Oh, really? Makes sense.
Well, no. Did Brian have asthma?
Yeah, Brian had asthma too.
My older brother had asthma. He passed away a while ago, but he also, so it made sense to me. It's kind of cool seeing that, it links up. And then the insomnia one too. That to me, I mean, I already try very hard to get good sleep, but to me, it's all of this stuff. I work out a lot. I eat pretty healthy for an average person, I would say. But I'm very invested in my health. And to me, doing something like a genetic test, or I just got my blood work done a couple months ago just to check everything, it's just an insurance policy. Like maybe everything's perfect, but not perfect, but it's not out of range. To me, that's good. That's still useful because I know I'm not missing anything, versus if there was something potentially very wrong, I would catch it earlier.
And you don't miss your health till it's gone. I mean, once your health is gone, it's too late, right? So
yeah, 100%. And I think, for me, one of my highest risks was actually schizophrenia, which is interesting because, you can be very high genetic risk for schizophrenia, but still low overall chance. And, in the platform, we really make sure we can explain the difference between that. But for me personally, I've never done any drugs, but given that risk, I'm definitely never going to do any drugs, specific psychedelics, right? Because I know my higher genetic risk. So the kind of range of insights between, Brian, me, and Kevin are, huge, you see here, and the kind of actions that you specifically need to take is really different. Also, I found out that I was high risk for migraines, which actually I wish I knew earlier, because of my entire life I had very bad migraines. Turns out it was genetic. No one thought even to, give a genetic test, actually, which I think is really fascinating. We would have addressed my care differently if we had known that as well. It's not video games, it's not some sort of food I'm eating, it's actually genetics. And then another thing I learned is about, because genetics, DNA, it's not just about kind of your health, it's just about your children's health. I'm actually a cystic fibrosis carrier, right? Did not know that. I'm also
you are, wow.
Yeah, I am. Yeah. And a carrier for another rare disease as well. And this is something we're actually going to be pushing the platform very soon. Brian, and probably more relevant for Kevin, because Brian, you already had kids, but you can see your own results too. And that's kind of the beauty of the platform, which is because we look at, all the chapters in your book, we can keep reading and analyzing them and giving customers more and more results, which I think is really exciting.
But is cystic fibrosis recessive? Mm-hmm. That's a recessive. Yeah. So, but if you marry somebody who has a recessive, then you have what, 50% chance of getting it.
Yep.
So that's the important thing. I mean, couples can take genetic tests. I mean, you can really find out what you're at risk
exactly.
of.
If my future, girlfriend also is a carrier, then there's a 25% chance of our child having the disease. And obviously you want to have healthy children. So risk identification and then action. And we have to wonder, why is this also not done at a population level? It really should be. I mean, in certain communities, it's already done more. It's more common, but this is very simple. I mean, it's not like you have to, again, it's not invasive in any way to swab. So, if a swab could save a future baby's life, that's kind of, common sense thing to do.
It's crazy. It's like what you're saying too. I think there's a lot of things where we scratch our heads and wonder why healthcare hasn't kind of evolved. And the pace of innovation in healthcare is very slow compared to every other field, or almost every other field. But there is no ever where you go take a genetic test, like you said, unless it's never required. Like you get blood work done sometimes, a doctor will have you do that, or you get your vitals checked. You never are told like, hey, let's get a DNA test for you.
But it's an evolution. I mean, people are much more engaged in their healthcare nowadays. With my chart, you can look at your results, and when I dictate an operative report, people, when they're in their room later that day, will ask me how the surgery go, and they've already read my opera. So people are gathering information about their healthcare more than ever, and this is such a simple thing to do, and it doesn't have to come from your doctor, right? You can order it yourself as a person. You can just get online, order the testing, and find out. And then you can discuss it with your doctor. If you want, hey, I'm going to increase risk for high blood pressure, glaucoma, diabetes. What can I do now with this genetic information that I found out on my own? What can I do to change my lifestyle? And so that's where I see the power of it. And you don't have to wait for somebody else to order it for you. It's been brought to the average person's level.
That's a good point. So right now, do you operate outside of insurance specifically? But I think you're HSA and FSA eligible, right? But you're outside direct. Do you have?
So what does that mean? Y'all explain that to people about FSA.
HSA and FSA, if it's health savings accounts and flexible savings accounts. So flexible savings accounts, you have to use if you have that in your plan. Like if you have to use it or lose it, is what people say. And then health savings accounts, it's like a tax advantage account you can have as well. But it's just kind of with plans, but you can use it for specific medical if they have the approval or there's something. that's gone through it, you can use it towards that. It's a qualified expense, I suppose. But yeah, do you guys, is that something you think that you're working towards, or you think is in the cards in the future, whether it's near or long term, with trying to integrate within kind of health insurances?
Currently, if you look at when a whole genome test is covered, if you look at United Healthcare, for example, they will cover a whole genome test if a baby is effectively incapacitated and there's literally no other diagnostic test they could possibly run to determine what's wrong with the baby. And this is after the baby's born.
Yeah.
And it is literally that extremity of case where then they will cover a whole genome test, which is very sad. So, that's another way of me saying that I don't think insurance is going to cover this test anytime soon. I think we have to kind of build it outside the system. And hopefully as it scales up and gets cheaper and cheaper, we can integrate it more and more into kind of, clinics. So that's something that we're kind of actively thinking about.
Yeah. No, because I'm thinking about it from the standpoint, and Dad, you might be able to answer this a little better, is from a physician standpoint, it then becomes harder to recommend specific companies. I would think about like a genetic test, say, or something else. Just like when it's to refer a specialist within the system, if they're not part of your system or
I see what you're saying. Yeah,
you know what I'm saying? Like there's only certain things like within Epic or the EMR, right, that you can recommend. Or
I mean, if it became a dedicated service that your hospital system uses, they may want you to do an internal referral. Hospital systems want you to refer to their physicians, their MRIs, their CT scanners, because it's part of their system. But I mean, it would have to become integrated into the system. If there was a specific genetic test that, say, my healthcare system used, I'd have to refer that person for that genetic test. But we're not even.
Yeah, no. So it sounds like a lot of stuff is just still. That's why it is. It's kind of to me. Like when you guys were both defining preventative medicine, I think another huge aspect of preventative medicine and kind of a lot of things in life is you really have to be a self-starter on stuff. Like no one else is going to care about your health like you will. No one else really cares about it. Not in the same way, because it's ultimately your health. It's ultimately your life and what's going to happen. I mean, Dad, you probably see this. Like how many surgeries do you think you do per year?
Like 350.
Yeah, so 350 people, you're never going to, I mean, unfortunately, just
nice.
like the same 300 for each of those people, that's probably their biggest procedure of the year. Like it's one of the biggest days, of their year. And that's something that's routine typical for you. So I think it becomes that with these things is you kind of have to kind of take the initiative, go find stuff, learn more about things, and get some of these things done. But yeah, we both took, I think it was in July. We both took the genetic test. Our results got back in 2 weeks, and it's been really cool to see too. And we could talk about this some more, but I think it was 20 things it was showing on our dashboard at first, and now it's up to, what is this, 26? So how you guys, when you take the DNA, it's sequencing all of it in that stored or however else, and then you guys are slowly kind of rolling out more reports and more things that you show on the actual dashboard.
Well, or is it like, I guess what we say, so you take the test once in your lifetime, you have that data. As you start finding more markers for diseases, you'll give people results. Like, do you have their DNA so you can keep testing it for, you see what we're saying?
Yeah. That's one of the key parts of the platform where, we can add more analysis to it. And also we can update analysis as new research is discovered. Genetics is constantly evolving. So it's not just that, we provide analysis on what will eventually be thousands of conditions, right? It's around 20 right now. Soon going to be 800 and then thousands. So it's good. Platform's going to grow in that way. There we analyze your same DNA. It's just one test, one swab, one time. We have your DNA then.
Yeah.
And then the other hand is research gets actually better. So maybe for analysis we gave you, scientists discover some new genetic markers. They build some new models that we can actually better gauge someone's risk.
And how do you ensure somebody doesn't steal your DNA? Because I'm sure people think about that as like, you have my DNA. So
yeah.
How's that?
We're actually we're a medical provider, so we're bound by HIPAA. So the same way when someone goes to your office, Brian, you're bound by HIPAA, or a hospital, they're bound by HIPAA. As a medical provider, there's a lot of restrictions with what we can do with someone's data. So we're CLIA certified, we're CAP accredited. By default, we don't share any genetic data or any protected health information with any third party. A lot of basically common sense procedures that by operating and navigating as a kind of medical test, but actually as a test that exists and that's ordered by physicians, we follow regulations that make it much more strict in how we handle people's data versus like a consumer genetics company. It's not physician ordered. They're actually not bound by HIPAA. A lot of people don't know that they're not actually bound by HIPAA. They're kind of in this regulatory gray zone. So there's a lot more of what they could do with the data. We took a much different approach because for us, nothing was more important building a company that had privacy and security first.
Yeah.
And is the actual DNA stored somewhere, or is it just the data stored in a computer? You know what I'm saying? Like the specimen,
the symbol. We actually discard the
discard it. Okay.
specimen.
So the
after
DNA
like 60
sample is
days.
gone. The only thing stored is the data that
Yeah.
you got from the sample. Yeah, okay.
Is that the risk of just like a third party company that's, with all the data being stored in like a computer, or is it all stored in the cloud? Or
Yeah, it's not stored on a computer. Well, it's stored in the cloud, which in a way is the computer.
yeah.
But yeah, I mean, we follow very similar kind of procedures to, hospitals. What I think is interesting is when people go to, a hospital, they don't often think to themselves, what is this hospital going to do with my data? They go and they kind of have this underlying expectation that they're going to be, taken care of. And so in the same way, when you go to Nucleus, we're actually a medical laboratory. And because we're a medical laboratory, we have to operate under frameworks and regulations and security measures that go to great extent to protect data. Obviously, in this case, your genetic data. So yeah, that's how we kind of view it as a company.
Got it. No, yeah, that's an important distinction. If you feel yourself more as a medical lab versus a technology company.
We are. We're literally a medical provider. That's how we're viewed as the government. We're a medical provider.
Yeah, I did not know that because I think some people definitely have a distrust with their data with any company these days.
Yeah, and I think 23andMe was a bad rap because they did not follow the same framework and they didn't have good communication or good practices. And you look at the recent hack, there was not even 2FA enabled. Not even 2FA enabled. I mean, that's really, really bad. I mean,
can you say what 2FA is for?
2FA is just a way. So, when you log into your account, sometimes instead of just directly logging into your portal, you have to actually confirm that it's you via some sort of code sent to your email or code sent to your phone.
Yeah.
So for example, if I was going to log into Nucleus, every single time I log in, I have to independently confirm that I'm actually the one logging in. And the reason for this is theoretically, if there's some sort of hackers, and this actually what happened to 23andMe, and they, someone's using the same username and same password, they could actually log into 23andMe's account. But obviously, if there's a 2FA, then they have to get access to the email or phone, and odds are less they have access to those things. And then that basically creates a measure where your data is far more protected, and that's one of many different preventers. That's just one that customers actually see and interact with a lot. So for us, that's like table stakes, and it's very disappointing, I think, for the first generation genetic testing companies that they weren't actually even 2FA enabled. I mean, this is someone's sensitive information. You have to take much greater care.
Do you think that sets you back or sets you forward / apart from them? Because in one way, then if people saw the 23andMe hack, then they're even less likely maybe to want to give their DNA. Or is that an opportunity for you to show like, hey, we're leagues beyond that?
I always think of these things as an opportunity for us to really give people insights that can save their life. Because ultimately, I think that's what we're about. And I think over time, what's going to happen is, as people the genetics industry needs to rebuild trust. It's interesting because a lot of genetics is actually clinical genetics. A lot of people don't even know about those companies, but those companies exist and they're ordered in hospitals, in various specific cases, but there's still, there's some volume of clinical genetic tests being ordered. And I think people in good faith know that if there's a clinical genetic test being ordered, I gave the example of like the Medicare patient, for example, after they've been diagnosed with cancer, they know in good faith that the DNA data and the entire process is kind of in good hands, right? It's for medical care. And I think people, when they do different diagnostic tests in a hospital or doctor environment, right, they're focused on their care. And they can have the reasonable expectation because of the laws of this country that their data is going to be kept in good hands and not shared inappropriately. So I want people to take that same approach when they come to a medical provider like Nucleus, and we give people insight. So in other words, what I'm saying, Kevin, is it's already kind of baked into the way people view their care. It's just a matter of recognize that we're not actually a direct-to-consumer genetic testing company that focused on, genealogy or hair color. We really focus on medical grade insights, and as such, we actually follow the same practices, as Brian does in his office, or a hospital does.
I have to ask you too, like a long time ago when you thought about you getting your first they didn't even have the genome. Remember, the genome wasn't even sequenced, the whole thing.
Yeah, that's
But
true.
when I would think about somebody sequencing a genome, and you think it's in a big laboratory and it's going to be $100,000 to do it. And I don't know what it used to cost to do like what you do, almost 100% of your genome. But what did it used to cost in the old days? I mean,
So this is actually one of my favorite stats. When in 2006, which is when 23andMe got started, the cost of reading your entire deed of your DNA, so all 1,000 pages, if your DNA is a 1,000-page book, all 1,000 pages,
yeah.
was $10 million per sample. 10 million per
Wow,
sample.
that's crazy.
So to think about that, and that's why actually these companies like 23andMe, they used older technology. So instead of reading all 1,000 pages, they look at one page. The
Right.
reason for that is because it was too expensive. You
Mhm.
couldn't possibly read the whole thing. So now we're in a situation where we go from $10 million per sample to literally just a couple $100 on Nucleus's website. And the best part is that's only going to keep coming down.
And
So
how do you do that? Like, how did that happen that it came down so much? I mean,
it came through one of our partners. So we partnered with Illumina, which is one of the largest sequencing companies in the United States. So if you think about how this works, you take a swab, stick in the tube, goes to a lab. The lab gets loaded onto a machine. The tube gets loaded onto a machine. That machine's an Illumina machine. It's like the infrastructure layer. Off of that machine comes out a raw DNA file. So the magic of Nucleus begins when the magic of Illumina ends. So your sample goes from a buccal swab to a raw DNA file. So that process is Illumina going from a raw DNA file, all the analysis, the informatics, the models, the risk calculations, to results on your portal. That part's Nucleus. So if you look at the Illumina part, they basically made machines more massively parallel, faster, better, right? So it basically became, if you look at sequencing as like entire life cycle, what happened was it was literally at some point a manual process where someone to sequence a little slit of DNA would literally go, and they would whatever, take their pipette, take different reagents, and they'd basically sequence a very, very small bit of DNA. And what happened is at first that process became automated, and then scientists realized that they could actually do that process in a massively parallel fashion. So then these sort of build up on each other to the point that basically the cost of actually sequencing whatever, a million bytes got cheaper and cheaper and cheaper and cheaper and cheaper. And then obviously, computation got cheaper and cheaper and cheaper. And so like there's so many different trends that kind of converge here. And that led to the inevitable decrease in price, dramatic decrease in price. And it's not done yet. I'm on the record for saying the next 5 years, the cost of sequencing is, I think, going to drop again by 10x. So we're talking about a whole genome as cheap as your lunch. I mean, it's going to be crazy.
That's crazy.
Yeah,
with the accuracy that you want,
with 99.9% accuracy, and that's what's so amazing. So there's going to be a world where a baby's going to be born and their genome's going to get sequenced. That world is coming. It's coming very soon. The idea of that we live in a population where you didn't have your genome sequenced, it's going to seem crazy. That's what I think is going to be so excited about the future.
Well, that's another thing I wanted to ask you about. So my nephew's 2 years old. I was looking up some of the different concerns about, does Nucleus have a specific policy for people under 18? And what are your thoughts on people, like kids, getting their genome sequenced?
Great question. We don't currently serve individuals under age of 18. If we were going to do something like that, obviously you have to get the parents' consent. There's also different kind of ethical considerations for us to mull over. One of which is, often, parents can consent for children and they can know they maybe have something, but there's always this question of, especially if it's a later onset variant, like a BRCA variant, should the parents know? The children shouldn't know. When the children's 18, does the parents then just give the genetic insights to the kid? I mean, again, I think it ultimately it's up to the liberty of the patient to decide. I think it's the liberty of the family to decide. But there's still, we want to be kind of thoughtful in kind of the information that you give. That's what we do. We give information, and part of our job is to do that information thoughtfully and carefully. So I think it's definitely something that in the future we'll be interested in doing more and exploring more, because I definitely think that parents would be really interested in getting their kids a genetic test. And obviously I do think from a young age, genetics is like the blueprint. So it is actually the thing that when, you're doing your most formative years, you take different preventative measures, genetics can be extremely useful. It's just another tool in the toolkit, right? In the same, so From that
Yeah.
perspective, you think about the different kind of diagnostic tests we run for children. Genetics is just another diagnostic test that you can run. It's just another lab test, I should say, more specifically. It's not always diagnostic. It's another lab test you can run. So that's the way we think about it.
What other companies are out there like yours that do almost 100% of the DNA?
From a clinical grade perspective, there's basically no one. There's some research tools that you get your whole genome done, but they're often leave patients down basically bad directions because patients don't actually know what they're getting. They're not validated. They give you different potential markers. It's really, honestly, actually an unfortunate part that someone might think that's what genetics is about, because that's definitely not what genetics is about. Genetics is not about creating a kind of medical mystery for someone, right? When often not, they actually don't have the thing that the test suspected. It's about giving patients really high quality and actionable results. And that's also why we've, I think, attracted so much financing. We've raised at this point over $20 million for some of the best investors. And, if you think about the kind of history of consumer genetics, there's really the only precedent of a company that's raised that much capital is 23andMe. That's the other, and that was obviously 20 years ago. So
I think it helps too. You can tell you definitely have a lot of passion and purpose around genetics and everything you're doing. So I think that goes a long way in people wanting to support that. But I think it's really cool what you've done. It's just by chance that we saw and we reached out to you. I think your team this summer, but I mean, it was really cool
with Kevin and I in social media. We have a platform that we've created here, but we only look for things that I think are going to move society. I mean, that's what we do. We do things that we think are going to be really good players in society for the future. I think this is one of them. We're big on alcohol prevention, and I think a lot of education there can help society in that regards. But I think your company is something that's going to move society along in the right direction, especially with healthcare and disease prevention, and or at least treating a disease ahead of time.
Yeah. No, I think it's a good asymmetrical bet too. There's obviously there's cost involved, just like with everything, but there's not much downside other than the cost of getting your genetic test done. And then you get to see all those things. And I think the huge part of it, like I'm 27, I have that the rest of my life now too. And especially as more stuff comes
keeping
along.
Updated too. That's the best
part.
That's
the thing. It's almost like Tesla. It's like a Tesla car, right? He always updates the computer for free the rest of your life, right? Or the rest of the car's life. So it's kind of the same thing. You're upgrading people for one test, you get upgraded the rest of your life,
Exactly.
Kind of cool.
Yeah. So
you ought to call Elon Musk and discuss this one.
I call Elon.
But the kind of last thing I wanted to ask, and you've talked about it a bit, but I don't know, what's your vision or long-term mission with Nucleus? You've talked about as cost comes down more, or if, potentially kids or younger people, or is there any other big, like, audacious goals you have?
Yeah, absolutely. I think what we really want to do is build a real-time, consumer-centric, quantified health platform. What does that mean? That means eventually the platform should be able to say, hey, Keon, as a 24-year-old male living in Brooklyn, wow, you had super high LDL levels in your last blood test. That's actually no surprise because you're in the 95th percentile for your genetic risk for high cholesterol. We found people with similar sex, age, and genetics as you saw a 10% reduction in their LDL levels when they did this specific workout tracked on their Apple Watch. Bringing the pieces together, the different diagnostic and lab tests together, that is the future of healthcare. That is the future of medicine. And that is how you build a true preventative-based healthcare system. Genetics is just the beginning.
Yeah, no, I think that's perfect. I mean, that sounds awesome. That's perfectly actionable insights, which I think a lot of people, especially in today's world with social media and everything else, or as me and my dad always joke about, Dr. Google, where people, if they don't have they crave information. If it's not from good sources, they'll find it somewhere. And there's a bunch of bad sources in the current digital age.
That's very true. That's very true.
But thank you so much for your time, and we really appreciate it. And we're very excited to be partnered with Nucleus. If you guys, if it was interesting to you or you wanted to learn more, you could go to Nucleus's website at mynucleus.com. And if you're interested in trying genetic tests, you can use code Heflinger. That's HOEFLINGER for 30% off. And we both highly recommend it. It was really easy to do, and there's a lot of power to it. So
yeah,